All right, let's talk about nomenclature now. Same kind of rules as before. We look for the longest continuous chain. So in this example here, 1, 2, 3, 4, or 1, 2, 3, 4. So there's something happening at 4 here, but then here there's the alkyne. So notice that alkynes are going to take priority over alkanes and alkyl halides, but not over alcohols. What I mean by takes priority is the alkyne gets the lowest numbering possible. So it doesn't matter where the halogens happen. The halogens could have been happening over here at 9. It doesn't make 9 turn into 1. Okay, the priority's with the alkyne. Chain of 9 is non-ine for alkyne, so that's an important ending you need to use. And then we do dashes between numbers and letters and commas between numbers and numbers. Don't forget mono, tri, mono, di, tri, tetra, etc. And then we always list them by alphabetical order, but by the way, di doesn't count, so we're alphabetizing by I. The only ones that do count are iso and cyclo, and then neo, but you don't really see that very often. So we're alphabetizing by C, I, and M. For this one, notice 1, 2, 3, 4, 5, 6, but they've actually named it so it's 3 all. All is for alcohols. 1, 2, 3. So last quarter I covered alcohols. So I snuck them in here, but I know some of you may not have had alcohol nomenclature yet. So this will be something we come back to later. So alcohols get priorities over alkynes. That's why we go 1, 2, 3 instead of 1, 2, 3, 4, 5, 6. So this will be 5-methyl, 7-octyne, 3-all, and ine meaning triple bond, and 3-all, meaning alcohol. Now when we have a double bond and a triple bond, you may think a triple bond's better than a double bond, but it's definitely more oxidized, but in nomenclature terms, they actually tie for priority. So then you just go by whichever one results in a lower, whoever's on the end first, you count in from there. So see how 1, 2, 3, 4, 5 versus 1. Okay, so this guy's going to win. So we just go with 1 there. And then let's say that the double bond was here and the triple bond was way over here, so they could both be number 1. Then you would go with the alkene being number 1, because ene would be before ine. And then last example, we have the parent in a ring. So this is a cyclohexane, but we have a triple bond that's outside of that parent chain, so we want to name this as a substituent or a group off of the parent chain. So in that situation, we're going to use ethynyl, so an inyl ending, and that's going to help us stick that in as a group off of the parent chain. So ethynyl because it's 1, 2 carbons. And again, we numbered the ring this way because we have 2 groups on carbon 1 this way. So it could be 1, 1 instead of 4, 4. And of course, don't forget cyclo when you have a ring. Okay, so let's just practice with a few of these and I'll post the answer key. So mainly just focus on alkyne here, and if you can, work in some alcohols and alkyl halides as well. So I'm going to try to number this longest chain, and it's the same way the other way, 1, 2, 3. So the alkyne starts on 3. And remember, you have to number through the alkyne. Well, there's nothing else you can do. So 1, 2, 3. So this is going to be either 3-hexyne, or you can say hex 3-ine. Either one is fine. This one I think is always less ambiguous because it's right before. The locant is right before the ending, or the indicator for what functional group you have. But here, as long as there's only one functional group, it doesn't really matter. And then for this one, this looks like an isopropyl group, but I wouldn't call this 1, 2, 3, 4. So it wouldn't be 1 isopropyl, 1, 2, 3, 4 butyne. It would be, you have to number the longest chain containing the alkyne if possible. So we either go this way or we go the other way. And I think you guys know we have to go this way because of the branching. So we want a 2-methyl 3-hexyne or a 2-methyl hex 3-ine. Okay, I don't know about you guys, but I get bitten up by mosquitoes everywhere I go. They find me and they just, it's terrible, and my legs swell up and it's really gross. So anyway, citronellol is a compound that sometimes people use citronellol oil or candles to keep mosquitoes away. So here's citronellol, and there are some reactions you can do to turn it into an alkyne. So what would the name of this alkyne be? And they didn't tell us if this was R or S, but there's a chiral center here, remains on this carbon. So that's telling me actually, by the way, somehow this group is being converted into this group, which soon enough you'll learn how to do these kinds of reactions as well. But for now, we're just going to ask you to name this molecule and try to also figure out if this is R or S. Go ahead and pause it and name the molecule and put an R or S designation on that. Okay guys, so far I have an octyne, so it's oct1-ine or just octyne or 1-octyne. The ones are sometimes dropped, so you can drop it if you want, but I like to include it just to be super clear. And then we have 3,7-dimethyl. All right, now for R and S review. It's been a while probably, so let's do that. So we have this carbon, we have 4 different groups on it. Okay, so first, for the groups that I see, I have this carbon, and that carbon, and they all tie with each other, except for this hydrogen here. I guess we could draw that in now or later. So now, since they all tie, I look at the next heaviest on each of these carbons. The next heaviest here is another carbon. This carbon has this carbon. Let me do this in different colors so you see the stages. This is what I'm looking at next versus this versus this. So clearly this is number 3. This is number 4. And then between these two, who has a greater priority? Well, we keep going. So these two are the same. These two are carbons. Now we go back to these two again and we say, what's their next heaviest one? Now this one's triple bonded, so I'm treating that as 3 single bonds. So here's 1, 2, 3. So I'm actually expanding that out. A triple bond for the Kohn-Ingold pre-log rules, which we're using to determine priority. It's based on mass of single atoms, not of a whole group. And double bonds are treated as 2 single bonds, triple bonds as 3 single bonds. This carbon's next heaviest hitter is just a hydrogen. So at this point, this guy wins because of all these carbons here, okay? So this is going to be my group 2, and this is going to be my group 1. So I have 1, 2, 3, so that's clockwise. So normally clockwise is R, but priority 4 is in the front, so that reverses my rules, R instead of S. So clockwise is R, but I had to switch the rules because I'm looking at it from behind, okay, because the hydrogen's in the front instead of the back. Now here it's only one chiral center, so I can just put S. If you had multiple chiral centers, you'd have to say 3S, 4R, put the number in front of the S or R. And if you didn't follow what I just did now, I recommend you go back and look at my stereochemistry lecture, or just YouTube search R and S configuration and you'll find someone talking about it.